Welcome to The Explainer. Today, we're diving into application security. Think of it as the invisible shield that protects pretty much everything in our modern world. All the apps, the websites, the software we use every single day. So let's just jump right in with a really important question. What does it actually cost when a software bug gets out into the real world? And I'm not talking about just a minor glitch. The financial hit can be absolutely staggering. Just to give you a sense of the scale here, get this. A single security flaw can cost up to 640 times more to fix after an app is released, compared to catching it when the code is first being written. I mean, think about that. That's the difference between hitting backspace a few times versus having to recall, rebuild, and redeploy an entire system that thousands or even millions of people are already using. And here's the thing you have to remember. Nobody writes perfect code. It just doesn't happen, especially in really complex software. So if every bug is a potential security hole, that 640 times n number suddenly becomes this huge financial motivation to find these problems as early as humanly possible. So you might be wondering, why would anyone wait so long to catch these bugs? Well, to understand that, we've got to take a look at how software used to be built. It was this thing called the over-the-wall method. Back in the day, the whole process was like a one-way street, a straight line. The designers would do their thing and pass it on to the coders. Then the coders would finish their part and pass it to the testers. And then, finally, it would be released. Every single step was its own little kingdom. And what this did was create these massive communication silos. Developers would literally finish writing their code and just kind of lob it over the wall to the operations team, the folks who had to actually run the thing. There was almost no communication, which, as you can imagine, created a real us versus them kind of vibe. This quote right here just nails the problem with that old model. Security wasn't even part of the process. It was just an afterthought, something you tried to bolt on at the very end. And of course, that's the worst possible time to do it. It's when it's the hardest and, you guessed it, the most expensive to fix. So yeah, that old, rigid way of doing things, it had to go. And that's what led us to a much more modern and much more secure way of building software. First, we got DevOps. And DevOps basically took a sledgehammer to that wall between the developers and the operations folks. Instead of that straight line, it created a continuous loop, a circle of feedback. The teams weren't separate anymore. They were working together. But the really crucial step forward was DevSecOps. That's when we put security, the sec, right in the middle of everything. It's not the last step anymore. Now, security is a part of every single phase, from the moment the first line of code is written all the way through to deployment and beyond. And this gets to a really core idea called shift left. Just picture the whole development process as a timeline from left to right. In the old days, security was way over on the right at the very end. Shifting left means we drag it all the way to the beginning, making sure we're thinking about security from day one. This whole new way of thinking really rests on three big pillars. First is security by design, actually planning for your systems to be secure from the very start. Second is real collaboration between all the teams, devs, security, ops, everyone. And third, using automation to make security checks a fast, repeatable, and consistent part of the process. Okay, so we've got this new mindset, but what does that actually look like for a developer on a typical Tuesday? What's in their playbook for writing secure code? Well, their toolkit has a few absolutely critical things in it. For starters, basic secure coding practices, like always checking the data users are typing in. Then there's using only trusted code libraries from reliable sources. And finally, keeping a software bill of materials, or an SBOM, which is basically just a detailed list of every single ingredient that went into the application. And if you want a perfect and kind of terrifying example of why that last part is so important, just look at the Log4j vulnerability. It was one tiny flaw in one super common, trusted piece of code that caused this massive global security meltdown, hitting millions of systems almost instantly. But here's the thing that's a little bit wild. Even with all these new ideas and better tools, as an industry, we keep making the same kinds of mistakes over and over. The list of the top vulnerabilities doesn't really change much from year to year. That's where things like the OWASP Top 10 list are so useful. It's basically a cheat sheet of the biggest and most common security risks out there. Things like not properly checking who has access to what data. It's become a really important guide of what not to do. So how do we finally break that cycle of making the same mistakes? Well, a huge part of the answer is using automated tools to help us out. Now, you'll often hear about two major types of these tools, SAST and DAST. Think of SAST, or static testing, as a white box test. It's like a spell checker for your code. It reads the source code itself to find potential problems before you even run it. DAST, or dynamic testing, is the opposite. It's a black box test. It acts like a hacker from the outside, poking and prodding the application while it's actually running to see if it can break. And here's the really important part. You don't pick one or the other. It's not SAST or DAST, it's SAST and DAST. They find totally different kinds of problems at different times. A really solid security plan uses both of them to create multiple layers of defense. Now, of course, we have to talk about the new tool that's changing absolutely everything, AI chatbots. And for developers, this is a classic double-edged sword. It brings some incredible benefits, but also some really serious risks. I mean, on the one hand, AI can write code and help you find bugs at lightning speed. It's amazing. But on the other hand, it can also accidentally create brand new security holes. Or even worse, if you paste your company's secret code into it for help, you might be exposing that code to the entire internet. And this all leads us to a massive and so far pretty unanswered question for the future. As we let AI write more and more of our software, what happens when it makes a mistake? If an AI builds a catastrophic security flaw, or even a deliberate backdoor, who's on the hook for that?